Howdy again, it's Tubalcain, your YouTube shop teacher, and this is tips number 538, which is part 9, and there'll be one more part yet, of the Mead band sander rebuild restoration. And I'm just about done with it here, but one thing I'd like to do yet today, which is kind of a major step and really a step back, but let's get on with it and I'll show you what I'm going to do. Before I start, let me make a few comments here about the speed of the belt. Now, they show in the original specifications here that we are running at 1600 feet per minute with the 1750 motor, and then they talk about the pulley sizes there, but I'm going to go ahead and measure the belt speed and show you what I'm actually getting with my little RPM meter. Using my little Epic speedometer here, and the red is surface feet per minute. That's feet per minute. So measuring the back side here, so I don't wear my wheel out, the back side of the belt, you can see that I'm getting about 2,000 feet per minute of belt speed. Now, that is much slower than the Kalamazoo, so let me show you what that reads. Now, the Kalamazoo reads about 4,500 feet per minute, but remember that this is a 3450 motor and what is that, almost a 5-inch wheel, 4.5 or 5-inch wheel, so that really speeds it up. Well, why am I telling you this? The speed on the Kalamazoo here approaches the speed of a regular grinder with a grinding wheel. And when I grind steel, watch the amount of sparks. Now let's compare that to the Mead. All right, now the Mead. Can you see? And they're both 100 grit belts, and this is a new belt really compared to the one on the Kalamazoo, but you can see that the Kalamazoo is much more aggressive and more like a grinder. Now, I suppose this could be outfitted with a higher speed motor, a 3450, and then you would get that grinding speed. But this really is satisfactory for deburring and a lot of other operations. And remember that in the original literature, they advertised this as a deburring machine. All right, that's enough on that. Let's get back to the business at hand. In the original sales literature, number 4 here brags about it being a precision ground tabletop. And of course it was cast iron. Mine is aluminum, and in an earlier video I told you that that's flat enough. My casting is flat enough for what the purpose is. But I changed my mind. I think I'm going to go ahead, I am going to go ahead and machine this tabletop. And I'm going to do that on the lathe. Now at the high school with the Peterson Products model, we used to do it on the milling machine, and I think I pointed out to you that we had lugs on the side so there was some way to hold it down. Well, there are no lugs on this, and I don't feel like doing it on the milling machine. That leaves a lot of machining marks on it, so I want to do it on the closing lathe. And in order to do this, we need a lathe that has a swing of really more than 10 inches. So this could be done on an 11-inch lathe, but in fact, the closing is a 12-inch lathe, so this will swing in a 4-jaw chuck. I also wanted to point out that I did put a little bracket here riveted onto the guard and screwed onto the machine itself, which really makes it very rigid and will prevent any possibility of rattling or any other annoying noises that it might, chattering and so on. Also, I cut off the extra length here on the stud. So now I'll take the table off. I took the chuck off, and it's on the bench here so I can talk a little bit about it in the horizontal position. If I had it to do over, I would have machined this surface before I cut the opening right here. It would have held better, and there's less chance of it compressing or chattering or any other thing that you could think of that would annoy a machinist. Well, I'm going to lay it in here like this. I've already reversed the jaws, and I was worried about this slug here hitting, you know, that I would have to raise this up out of the jaws, but I'll show you in a second that it does clear, but just barely. Now, rather than just bring the jaw right across here, I'm going to lay a tool bit, just a piece of scrap. It could be just scrap, and that will straddle this. Also, I suppose cause it to be a little bit firmer and more rigid in here as I tighten it up. Another thing to note here is I barely have clearance here between the work and the jaw, but laying a rule across here, you can see that I am not going to strike the jaws, but I'm coming pretty darn close. But laying the Starrett rule all the way across, remember there's a dip here, some shrinkage on the other side of the lug. Talked about that earlier. So in order to machine that all out, I have to take, well, probably a full 1/16 of an inch off. I think that will cause the tool to run into the jaw. So I am going to lay some packing in here to raise it up just a little bit. So let me see what I can come up with. Be right back. Alright, this is cardboard like you find on the back of a tablet. About a 1/16 of an inch thick. Well, why am I using that instead of metal? For several reasons. First of all, it was readily available. I had some here on hand. Secondly, should these fly out as the chuck is turning, they aren't going to hurt me. If it was a little piece of sheet metal, it, you know, could be a hazard. So let's put that in there. I'll snug it down. Again, I don't really care if it's perfectly on center. Doesn't matter. And now I can see it's about in the position I want, and rolling it over just a little bit. I do have clearance here where the lug is, so the lug is not touching the face of the chuck. So let me mount the chuck on the closing and let's take our first cut, but I think I'll indicate it as well. Okay, the table is mounted in the 4-jaw chuck on the lathe, and I've spent about 10 minutes trying to get it all squared up. And remember that a casting is always irregular. It's not a precision piece, a sand casting, and the pattern probably wasn't precision. After all, it's homemade out of plywood. So there's some warpage probably in the pattern and in the casting. But right here I have the indicator on the 0. I know you can't see it, but I swing it around here to the opposite side. Note that I have a big button end on the indicator. So that was 0, and then 180 degrees over, well, it's 4 thousandths. Let's check the other way. And in the other direction here, that's just as close as I can get it. So I've zeroed out the Starrett indicator on that side. You got to be careful not to damage your indicator now when you come to a gap like that. And over here, well, it's, what, 8 thousandths? And then jump the gap. You can see there's quite a differential there. Now going back and forth, and you know, I spent quite a bit of time on this. That's as close as I can get it because the casting itself is irregular. So I'm going to go ahead and start machining. Okay, I'm taking a trial cut, and I'm 120 RPM and 10 thousandths feed, and I'm feeding out right now. You can see it's not cleaning up everywhere, but I didn't expect it to. And I'm using old technology here. I'm reverting back to an Armstrong tool holder with a 5/16 high-speed steel tool, because essentially I'm facing this, and a nice radius on the end, and I like the kind of finish that I get with high-speed steel. Let's go. One thing I like about a variable speed lathe such as this closing, on a large piece like this, as I'm facing, I really need a faster spindle speed when I'm near the center, but as I get out toward the periphery, I need to slow it down. But with this kind of lathe, I can change the spindle speed on the fly. So you may notice as I move out that I am slowing it down. Maybe you can't tell. Were you able to notice that I was changing the speed up here as I was feeding out to slow it down? Okay, you can see that I need another pass or two, and it still needs to clean up right here. And looking at this other one here, that's where the shrinkage is, you see, on the opposite side of this. Now that could have been reduced by proper gating, but it's kind of hard when you got a thick spot in the middle. So I probably would have had to put a riser right in here, but I wasn't in the mood because really this is good enough for who's it for. And this high-speed steel tool is really working out nice. It is a nice finish. Now, I had a laugh sometimes at the high school. Funny how you remember things like this, even though it's 35 years ago. Some kids would machine away and machine and machine until the thickness here was just no more than the thickness of a piece of cardboard, and then they would pretty much ruin the casting, have to start over. But they would get very discouraged, of course, which I would have too. I don't blame them. You can see that it's not quite cleaned up yet. There's a low spot there. Again, that's the shrinkage. So using the Brown and Sharp straight edge, laying that across as such, if I can get my hand out of the way, and there's a 7,000th feeler gauge, and even that fits in there rather freely. So I got at least 7,000ths to take off yet. There's still one little spot that did not clean up, so I have to make a final finishing pass, just a few thousandths, but it still takes another 10 minutes. You can see it right there. So that really was a sinkhole. The finish is quite good. So this is the last pass. I won't show that. Well, that completes the finishing pass. Will it be cleaned up? Yes, indeed, it did clean up on the final pass, and the job is done. Let's take it out. All right, it's from this to the finished product here. Always allow a little bit for machining allowance in your pattern making. All that's left is to knock off some of the burrs with a file. Oh, that's right, I have a deburring machine. All right, perfect. Let me get that mounted on there, and that concludes this part 9. Be sure and watch part 10, where I summarize the whole thing and show you different ways of using a Mead belt sander. So hope you enjoyed the video series, and I'll see you in part number 10. I had to take a little break and feed my sweet tooth, and I do mean tooth because that's about all I got left, thanks to all the candy I have eaten. Well, I went down to Big R, and they got a big old, this is Black Friday, and they had the Hershey's Pot of Gold. They got about 3 different kinds, $3.99, pretty reasonable, but of course they're fooling you because offhand you just grab it and think you got a 1-pound box, but of course you don't, you got a 10-ouncer. And then when you open it up, at least they tell you there are 28 pieces. Quite a bit of space in between here, so they're, you know, they didn't exactly pack them in. And I'm not pretending that Hershey's is Godiva or quality. I think the box is probably fancier than the chocolate, but I do love when a box of candy has a map on it, like the old Whitman's sampler did. So I'm going to start out with the butter rum caramel. Oh, that is pretty good, I have to admit. Matter of fact, the whole box smells very, very good. Alright, let's do some machining here. May I offer you a piece of chocolate? You can see I've been hitting them pretty heavy. Did you ever recall that, you know, sometimes you'll get a gift carton like this for Christmas, so you'd open it up, but the polite thing was to pass it around. And there were, you know, 10 people in the, and as you could see them pick through there, they would take my favorites before I had a chance.